Good morning, everybody, and once again, welcome to Pankaj's Echelon Tutorials. And as you must be knowing, we are into exercise 3.1 of Indices and Surds, that is chapter number 3 from Additional Maths for IGCSE 10th grade. And we were on to question number 7. Till the last video, I think that was video number 3. In that we had reached till question number 6. Question number 6 we had completed, so we are left with the last question, that is question number 7 from this particular exercise 3.1. So let us try to complete that and proceed with the other things. Okay, so the question says that simplify, that is question number 7 from exercise 3.1. It says simplify and uh, okay. Let's simplify 1 plus x to the power of 3 by 2 minus 1 plus x to the power of 1 by 2. Now you have to simplify this. Okay. Now basically in this you have these two terms which are separated by a minus. Okay. So what you can do is in these two terms, what is common, what is highest common factor that you have to remove out. Okay. So according to me, the highest common factor has to be 1 plus x raised to a 1 by 2. Okay, this is the highest common factor. When this is removed out, you will be left with inside. Now from the first term, that is 1 plus x raised to 3 by 2, 1 plus x raised to half has been removed out. So what will be left here? So the answer is, if you remove from 3 by 2, if you remove 1 by 2, okay, the answer will be 2 by 2, which is equal to a 1. Okay, so what will be left here is 1 plus x, which is the base, raised to a 1. Okay, and then a minus sign, and from this 1 plus x raised to half, that is from the second term, the entire term has been taken out. So here you will be left with just a 1. Okay, if you want to cross check it, just try to multiply out these two. Okay, this into this minus this into this, see whether you are getting the previous step. Okay, and you should get the previous step. Okay, now let us further go and write this as 1 plus x raised to a half. And now let us open this bracket. So it will be 1 plus x minus a 1, right? Now what happens? This 1 and this minus 1 gets cut and you are left with only a x over here. So your answer is 1 plus x. The answer will be 1 plus a x raised to a 1 by 2. And here you are left with just a x. So this is your final answer. You cannot simplify any further. So that was question number 7 from exercise 3.1, and we have completed exercise 3.1. Now further, we are going to deal with certain questions which are based on the solving of the equations, okay, in the form of indices. So when the equations are in the form of indices, they are many a times also known as exponential equations, okay. So how to solve this exponential equations, that is what we are going to learn now, exponential equations. Now, first of all, what are exponential equations? Exponential equations are equations which involves terms which are in the form of exponents. Okay. Now, for example one, now this is the example that I'm taking from your book itself, Additional Maths, and it says that 2 raised to 3x plus 1 is equal to 8, right? Now this type of equations are known as exponential equations because in this equation you can see on the left hand side there is an exponent involved. Okay, now before I proceed with the examples, let me tell you something about this exponential equation. There's a law which says that if a raised to a m is equal to a raised to a n. Now you can see here these bases are on both the side, left hand side and right hand side, the bases are the same, that is a. If that is the case, then you can always say that the indices or the powers are also same. So m is equal to n. Got it? And the reverse of this is also true. Or you can say if b is equal to m and if a is also equal to m, then also you can say because the indices or the powers are same over here, so a will be equal to b, the basis will be same. Now this is the fundamental thing that you are going to use in solving this type of exponential equations. Okay, so let us go by this only and try to see how we can find out the value of this x, because this is solve. Okay, here you have to, here it is not simplify, the question is solve. Solve means you have to find the value of x, okay, for which this equation is valid, right? Okay, so now what I can do is 2 raised to 3x plus 1 is equal to 8 is given to me. Now somehow I will have to see that, you know, the bases here are becoming same. So here the base is 2. So if I make this 8 as 2 raised to 3, 8 can always be written as 2 raised to 3. Then my equation happens to be 2 raised to 3x plus 1 equal to 2 raised to 3. Okay. Now, you can clearly see that on the left hand side and the right hand side, the bases are the same. Okay, 2 and 2. Therefore, you can equate the indices. That is 3x plus 1 equal to 3. You can always do that. You can write here, because when bases are same, okay, power is also same, right? This is what I have used, right? So 3x plus 1 equal to 3. Now from here it is very obvious, 3x will be equal to 2 and x will be equal to 2 by 3. So we got the answer for x. So what is the value of x? It is 2 by 3. Okay, that was a very simple straightforward example. Let us do a few more examples before coming to the exercise number 3.2 of this particular chapter. Okay, so let us try one more, and this is example number 2. This is also from your textbook, and it says that 3 raised to a 2x minus 1 times 9 raised to a x minus 1 is equal to 243. Okay, now this is also solved. Okay, you have to solve it. Solve means you have to find out the value of x for which this equation stands valid. Okay, now here again I can see here the basis as 3, 9. Okay, so everything I'll be trying to convert it in the form of base 3. So this is in the form of base 3 only. So let me keep this as it is. Now this 9 I can write as 3 square and then to the power of x minus 1. It works this way. And this 243 can be written as 3 raised to 5. Okay, because 3 raised to 5 is 243. Okay. Now you can see you are getting equation, exponential equation, in which you can see all the three bases to be same. Now further, I am going to do this 3 raised to 2x minus 1 into, now this will become 2x, 2 into x minus 1, 3 raised to 2 into x minus 1, that is 2x minus 2 equal to 3 raised to 5. Got it? Now what I can do is, because these two are same basis and there's a multiplication over there, by the first law itself, this will work out to 3 raised to 2x minus 1 plus a 2x minus 2. Okay? So I can write here a raised to m into a raised to n is equal to a raised to m plus n. Isn't it? Equal to 3 raised to 5. Okay. So on the left hand side, I have used this rule. Now this can be written as 2x plus 2x is 4x, and minus 1 and minus 2 will be minus 3, equal to 3 raised to a 5. Okay. Then now I can say that 4x minus 3 is equal to 5. Again, why? Because if a raised to m is equal to a raised to n, then this implies that m is equal to n. Okay, you have to keep on mentioning the reasons, okay, for the laws that we are using. Now from here you can easily find out your x. So 4x will be equal to 8 and x will be equal to 2. So I suppose you have understood how to deal with these problems on solution of exponential equations. Okay. Now let us try one more before we go to exercise 3.2. Okay. Or rather, let us start with exercise 3.2. No harm in that. Okay. So let us start with exercise 3.2. This exercise 3.2 is on page number 54. Okay. Of which book? Of course book, second edition. Okay. Additional maths by Sue Pimberton. This is that book which I am referring to. On this book, on page number 54, and the chapter number is 3. Okay. So, exercise 3.2, the very first question is question number 1. It says, solve each of the following equations. And in this question number 1, you have A. Subquestion A is 5 raised to a 2x is equal to 5 raised to a 7x minus a 1. Now, here you can clearly see, because the bases are same on the left hand side and right hand side, you can equate the power. So I can write here straight away 2x is equal to 7x minus 1. The reason is because if a raised to m is equal to a raised to n, implies that m is equal to n. Simple as that. Now I'll work out. So this minus 1, I'll bring it over here, and this 7x, this 2x, I'll bring on this side. So it will become minus 2x. So this becomes 1 equal to 7x minus 2x is 5x. So x happens to be 1 by 5. So this is the answer for A. Let us go for the B one. Question number B says that a 4 raised to 2x plus 1 equal to a 4 raised to a 3x minus a 2. Again, by the same logic, because the bases are same, I can write 2x plus 1 equal to 3x minus 2. Let me write the reason. This is because if a raised to m equal to a raised to n, implies that m is equal to n. Now what can I do is, okay, this is 1 plus 2, 3x minus 2x. This is x equal to 3. Fine. So that was B answer. Let us go for C. C says that 7 raised to a x square is equal to 7 raised to a 6 minus x. Okay. Again, because the bases are equal, I can write x square is equal to 6 minus x. Because if a raised to m equal to a raised to n, implies m is equal to n. Okay. Now this is x square equal to 6 minus x. Now this can be written as x square plus x minus a 6 equal to 0. You get a quadratic equation. Okay. So let us solve this quadratic equation. It is minus 6. Okay. So let us find out two numbers. So the two numbers will be, I suppose, 3 and 2, plus 3 and a minus 2. Okay. So this will be x square plus 3x minus a 2x minus a 6 equal to 0. Now if you take common from here, x common from these two, we'll be left with x into x plus a 3. From here, if you remove minus 3 as common, okay, you'll be left with sorry, minus 2 as common. You'll be left with a x, because minus 2 into x is minus 2x, and here it will be plus 3 equal to a 0. Now you can see you are getting a repeated bracket of x plus 3. So the products will be x plus 3 times this x minus 2, that is x minus 2, equal to 0. Now this will imply that x minus 2 equal to 0 or x plus 3 equal to 0. This in turn implies that x equal to 2 or x equal to minus 3. So these are the answers for your x for question number 1C. So x will be either 2 or a minus 3. It's a minus 3. Okay. Now coming to D part of question number 1. It says that 3 raised to 2x square is equal to 3 raised to 9x plus 5. So straight away I can write 2x square is equal to 9x plus 5. The reason being that if a raised to m is equal to a raised to n, that gives me m is equal to n, right? Now again this happens to be 2x square minus 9x minus a 5 equal to 0. This is a quadratic equation. Now let us solve this quadratic equation. And if you want to solve this quadratic equation, the product will be minus 10 and the sum is minus 9. So I'll take the two numbers as minus 10 and plus 1. Okay, these are the two numbers. Now these are the two numbers which when you multiply out, you will get the product as minus 10, and when you add them up, you will get the sum as minus 9. Okay, so 2x square minus a 10x plus a 1x. I've splitted this minus 9, okay, into minus 10 and plus 1. This is how you solve quadratic equations. And then this is minus 5 equal to 0. So these three terms are now converted into four terms. Now what I will do is from two terms, I'm going to take common out. So from this, the highest common factor will be 2x bracket x minus a 5. From here, I'll remove 1 out and I should get x and then plus and then a 5 equal to 0. This can be plus, no, this will be minus because I want a minus over here. Okay. This should be a minus, right? If you are doubtful, you can always open this bracket and check out whether you get the previous step or not. Okay, and definitely you should get it. Now this can be written as 2x plus a 1 in one bracket, and in second bracket the repeated bracket you have to write, that is x minus 5. This is equal to 0. Now this in turn will give me 2x plus 1 equal to 0, or x minus 5 equal to 0. So 2x equal to minus 1, or x equal to minus 1 by 2, or x equal to a 5. So these are my answers for x, minus half or a 5. That completes my question number 1, A, B, C, D from exercise 3.2. So good, we have started with exercise 3.2, and today's video I will end up here and here itself. And in the next videos, I'll be continuing with this exercise 3.2, and it has some 10 questions along with a lot of sub questions. So it's going to be a good deal of time that we'll be together in solving this exercise 3.2. Once this 3.2 is over, we'll be coming to the search part of this chapter. So till then, goodbye. Good luck, all of you. Take care.